In this video, we will learn how to format our outputs using Printf and String.format methods. So far, we know how to print output using print and println methods. However, the print and println methods do not allow us to format our output. Consider the following example. If you have a double number that may be a result of a division, Java will print it as a floating point number with 15 decimal places. This can be good. Imagine a money management application that prints a balance in this format. So we want to learn how to customize our output format. Before we do that, however, consider another example. Given an int variable called hours, which stores 40, how would you write a println statement that prints the sentence, "I worked 40 hours this week," such that the 40 comes from the variable hours? Alright, so a possible way to do it is to write a println statement that has multiple strings. You start with the first part of the "I worked" and make sure to have a space afterward, plus, then insert the variable hours, then another plus, and continue the sentence saying "hours this week." Then compile and run, and you will get "I worked 40 hours this week." But wouldn't it be nice if we can write the whole statement as a single string and mark the place where we want the variable hours to appear? Then somehow Java would plug that variable in the sentence and print the appropriate content. That would be great. Well, Java has a way to do that, and it's called the Printf method. Similar to the print and println, the Printf method is part of the system class and can be called using the out object. However, unlike print and println methods, it can take two inputs. The format string, which is the string that contains letters and formatting specifiers. The formatting specifier serves as the location and format marker. The second input is an argument list, which is the list of 0 or more arguments that we want to appear in our string, like hours for this case. Notice that we said the argument list could be a list of 0 arguments. That's interesting. So let's have a simple example with this. If we have a 0 arguments, the printf statement will take only one input, which is the format string. Consider this example. We will get this output if we use two printf statements with simple format strings, which are just normal string literals. Notice that the two separate printf statements were printed on the same line. What does that mean? It means that printf in its simplest form works just like the print statement. It prints the output and adds no new line character afterward. Alright, so how would printf look like if we had an argument? Something that is more complicated than just a string literal. Here is the example we had earlier. The first part is the format string with that marker in place, and the second is the list of arguments, which is a single argument in this case, the variable hours. Looks good. Now we need to learn how to write this marker to tell printf to show the contents of hours in this place. The marker, which is called the format specifier, consists of multiple parts, two of which are mandatory, the % and the conversion character. Everything else is optional. So what are the conversion characters? These are the characters that tell the printf method the format of the output you want to display where the specifier is placed. This is a table that shows 6 of these characters. The character D is used with the decimal integers, such as byte, short, int, and long. The character F is used for floating point numbers, such as the float and double. C is for character, and could be a char or a literal. If uppercase, the character printed will be uppercase. S displays strings, could be a string literal or a string reference variable. Similar to character, S uppercase prints the string all uppercase. The N is for new line, and the H is for hash code, which is the address hash stored in the reference variables to point at the objects in the heap memory. Alright, let's make this example of the hours worked work. Since it only has a single variable that is an integer, we are going to use the decimal integer D conversion character. And this is how it would look like to print the statement. Again, since the 40 is an int, we use the d for the decimal integer along with the percent sign to instruct printf as where to display the contents of the variable hours. Notice that you can use as many specifiers as you wish. For example, here is a sentence that prints how many dogs and cats we have. Notice that we have two specifiers, one before dogs and the other is before cats. We also have two arguments listed and separated by commas. Also notice that the pairing will be matched in the same order as it appears. The first variable dogs will appear where the first specifier is placed. The second variable cats will appear where the second specifier is placed, and so on. So let's make things interesting and start to learn about the other optional fields. The optional width field specifies the total width of the field in which the argument will be printed. This includes spaces and decimal points. Let's see how it works. Here we are using the percent sign and deconversion character to print an int, but also added an int literal 6 between them. If you run this, you will get the num printed with some space before it. If you count the total width including the 9, you will find that there are 6 spaces. Notice that the space before that is the space that is between is and the specifier in the string. Alright, so a single digit 9 appeared in 6 spaces because we specified the field width to be 6. So what will happen if we specify a width that is shorter than the number we want to print? What will happen is that Java will override your specification and use the minimum possible width enough to display the number correctly. In this example, even though we said print 1000 in a field width of 2, Java ignored us and printed 1000 correctly in a field of width 4. Let's now explore how to use the conversion character f to print floating point numbers. Here we have 3 double variables that we want to print next to each other. In this case, we placed 3 format specifiers with the percent sign followed by the character f. It will print the 3 with a single space between them because this is how we formatted the string. Notice that printf will print the floating point numbers with 6 decimal places. That is better than the print and print line, which had 15, but still, we need to learn how to control the number of decimal places. Again, if we specify the width to be 20, for example, it will print the number in a field with a width of 20. Notice that the 20 places will count the decimal point. Alright, so if we want to control the number of decimal places, would reducing the width of the field reduce the number of zeros that are printed? Here we try to limit the width to be 4, hoping that we can control the decimal places. However, Java still ignored us and printed each number with 6 decimal places. So clearly, this is not the way to control the decimal places in Printf. To control the decimal places, we need to use the precision field, which is a period followed by a number. The number specifies the number of digits of precision. Notice also that it will round the number. Here is an example with the precision set to 0.2. This way, it's printing only 2 decimal places. Also notice that it rounded the number to 3 since the next digit is 7. Now let's put the field width and the precision together. By specifying the total width to be 8 and the precision to be 2, we have the number printed with a total of 8 places, including the decimal point. We also have 2 decimal places. Alright, let's now explore the strings. Here we have a reference variable name that points at the string object Ringo. By placing it in the printf statement and make the format specifier use the conversion character s, we are able to print a string. Another example is with more strings. Notice that you can have a mix of string literals and string identifiers. Also notice that we get the new line behavior using a mix of escape sequence, which is \n, and the new line specifier, which is the %n. Alright, now one more thing left, the flags. The flags are used to change the behavior of a specific field. For example, you will notice that by default, the printed information is right justified. If you want to left justify it, you can use the dash flag. If you are printing large numbers that are greater than 1000, you can use the comma flag to place commas between digit groups. Here is an example of using the comma flag to print a large number. As you can see, Printf will automatically place the commas just because we use the comma flag. Printf is a very powerful method. You can mix and match all of these specifiers to print very nice formatted data. Here is an example that mixes strings with floating point numbers with fields and precision specified to print the data in a user-friendly tabulated format. So now we know how to format our strings as we print them. But what if we want to store a formatted string object without printing it? This can be done using the String.format method. In this example, we have the reference variable myString pointing at the formatted string that says I worked 40 hours this week using the %d specifier. Notice that once you have the formatted string, you can print it using the print or print line statements. You don't have to use the printf.